Good evening, everybody. We are going to give it a few minutes here and let people get in and get everything set up, and then we'll get going. Today, we're going to keep working on the, I'm going to call it the Plinko game, but it's normal distribution because it's not really a game. We're just kind of learning a little bit of math and trying to understand how the Plinko game works and where when you drop a disc, where it usually ends up. So let's give it just a few more seconds here, and we will see what it looks like, how many people we get in here. And it looks like Miss Megan's here in the chat tonight too. So if you guys have questions, put it in the chat, and Miss Megan will help you guys as much as she can. I'm going to be watching the chat too, so we'll see how everything works out and see who can help you. If you weren't here last week, don't worry about it. I have a version of what we have been working on that you'll be able to pull into your own Scratch account, and we will start from there. And so you have not missed anything. We're going to keep going. It'll not be a problem. You're just going to not have as much understanding as the code as maybe if you worked on it last week. That said, all the videos are still here on the YouTube page, so you can always go back and check them out and keep working on them. And it's not a big deal. You know, it's something you can do later on. More than happy to answer any questions too. Just put them in the comments, and I'm very happy to help out. All right, we'll give it just a couple more. I'd say about one more minute here, and then we'll get going. Okay, so like I said, we're going to work on the normal distribution today. Before we get going, I want to remind everybody that Tuesdays, we do have a Zoom classroom available. That is meant for you guys. Whether you guys just want to hop in and say hello, or if you've been working on a project and you need some questions answered, maybe you're working on one of the previous YouTube videos and had some questions, that's what we're there for. We're there to, take your guys' time and do the best we can with it. I do want to let you guys know that it may not be me in the next one. JD, even though JD has moved and he is no longer in this area, he still wants to help out. So if you guys know JD, he's one of our teachers. He will be in next Tuesday. So if anybody wants to, say hello to JD, get some help on some work from him, he will be there and able to help you guys out. At that point too, if you guys have anything that you're just interested in learning, that is a good time to jump in with us and say, hey, I'd really like to know how to do this. We might be able to help you there, or it might give us an idea for a future video. So that would be really cool. If you guys have ideas for future videos, we definitely want to know that. So let's get going on this project today. What we're going to do is I'm going to start off by showing you guys how to get to the project if you haven't already been working on it. So here I am in a fresh Scratch page. In the search bar at the top, we're going to type in future of code. It is all one word. And we're going to hit return or enter, depending on what your keyboard says on it. Now we have a couple games here, and these are all to do with different YouTube videos. But the one that we're looking at is down in the bottom here. You kind of see the one with the triangle. It says normal distribution. Now it might say normal distribution /WIP, or it might say /part 2. If you click on this, it has been renamed to part 2, so you'll actually see that. That should match what our YouTube video is, at least pretty close. Our YouTube video's name is Plinko normal distribution part 2. But this is where we're going to start. So if you also had any bugs with last week's code as well, this might be a good place to start. What you have is if you're signed in, there's something that says that you want to remix it. Go ahead and hit remix and save it to your account. Remix will mean that it is saved to your account, so if the computer crashes for any reason or anything like that, at least any work you've done on it is then saved. If you work on this one right here, it won't be saved because that's not saved to your account. It's still under my account. So let's get into the code. To get into the code, click See Inside, and that'll take you into the code here. And where we're at is we did the Plinko board built. So we got all the pegs put into the right spot, and then we got the ball dropping to the bottom. So we got the ball starting at the top and then slowly coming down and dropping to the bottom. So if I press the green flag here, you'll see there we go. All the pegs get started and get placed where they need to be, and the ball drops to the bottom. But then it just stops there. So Miss Megan, yay JD! I know, I'm so happy to have JD still helping out. Okay, so we have the ball hitting the bottom here, but that's where it ended. And we stopped the code. Here's the code for our peg, and if I remember right, the code for our pegs are actually done. We don't need to do anything else. And looking at my notes here, yes, they're done. So the code for the pegs is good. All the pegs really do is we just put them in place, and then we let the ball do the rest of the work. So let's go ahead and we're going to click on the tennis ball. And this is all we have in the tennis ball. We have some initializing code here. So we have it going to 0 and 170, which is all the way at the top here. And then remember, since it's a ball, we want it to move in a specific direction. And since it's moving downward, we need to point it in direction 180. This means that the ball is turned, even though there's no like face on the ball, there's still a direction for the ball. So we make sure that the ball's turned in a way so when it moves, it's moving downward. And we're going to see how that works right now in just a second. Because when the ball hits a peg, we want it to move left or right. So we're going to actually have to adjust its direction and which way it's facing. Again, facing is a relative term with a ball, but we're going to work with it. We're just going to go with it. That's why we use it, or that's why I used a tennis ball, is because you can actually see it kind of change direction and which direction it's facing. It kind of helps in giving an idea of what's going on with it. So where I want to start this time is I want to start with, we got the ball going from the top to the bottom, but once it hits the bottom, it doesn't do anything. Now what we want to do is we're going to keep track, when the ball hits the bottom here, we're going to keep track of which bucket it lands in. And I call it a bucket because in the regular game there's a little green dot that's going to be here. And that green dot is going to be kind of a bucket for it to land in. And we're going to track how many times it lands in that bucket. But when it hits the bottom here, we need it to come back to the top and drop again. So let's do that. We need to do... essentially we need to say, okay, the ball has hit the bottom, and when well, hold on. Never mind, we're not going to do that. We don't have the code ready for that yet. That's okay. What we actually need to do is when it hits the peg, when it hits the peg, we need to decide if it wants to go left or right. We got to wait for it to hit the bottom because we don't have our buckets in there yet. So, okay, let's get started here. We have a decision to make, and that decision is when I touch a peg, let's say this ball's dropping here, and when it touches a peg, right there, when it hits a peg, it needs to go left or right. So it has a decision, and that's a binary decision. Well, we've learned the last couple times we've been together that a binary decision does really well with an if-else statement. But the first decision we have to make is we need to know is this ball actively hitting a peg? At any point, is it touching a peg? Does it run into something? So that's the first thing we need to check for. And we're going to check for that using an if statement. So let's go to control. And in control, we're going to grab an if-then statement. Now here's what's cool, is we have this named peg and this named tennis ball down in the bottom here. We actually have an operator where we can tell if the current sprite we're in is touching another sprite, and we can identify that sprite by name. And I'll show you where this is. This is really cool, you guys. I really enjoy this. I use it a lot in different games that I've helped make. and it makes life a ton easier. So we're going to go to sensing. It's this light blue color. And in here, the very first one says touching mouse pointer. But if we click on the drop-down menu, that little arrow that's facing down, and we expand mouse pointer, we actually see, is it touching the edge, which we could use. And we also see, is it touching peg? Well, if we look down here, peg is what we named this sprite that represents our pegs. So let's go ahead and grab touching mouse pointer, drag this out, and we're going to change it to peg. Now what this is saying is the tennis ball touching the peg? And this gives us a true or false. Like right now, it's going to give us false. But if I let it drop, if I drop it right here and I keep hitting this, when I hit it right now, it's touching the peg, it's true, but when it's not, it's false. Now it's true, now it's false, and we're going to see true again. So you can see this identifies when two sprites are touching each other. So let's drag this into the if-then-else state, or if-then statement, excuse me. And now we know when it's touching a peg. That's our first decision to make. The next thing we need to do is we need to decide, all right, when it's touching a peg, we need to randomly decide, do we go left or do we go right? So let's start with the first part of this, is we need a random decision. This random decision can be a binary decision because it's only a left and right. There's only two options. So that means that it can be a 1 or a 0. In binary, we have true or false, 1 or 0. So let's create a random 1 or 0. Go to operators. And in operators, we have pick random 1 to 10. Let's grab that and we're going to drag this out. Just drop it anywhere on the canvas here. Now, right now, if I click on this, you'll see it picks random numbers from 1 to 10, but we only want it to pick anywhere from 0 to 1. So we're going to change this from 0 to 1. And what this is going to do is we will decide if it's a 0. Sorry if you guys are getting... YouTube's telling me that the video quality is not doing great. So let me know if you guys are having any issues or if YouTube's just acting up. One sec here. Alright, well I hope this picks up because everything looks good on my end, but I'm not really sure. YouTube is telling me that you guys might be experiencing problems. So tell me in the chat if you guys are experiencing problems, because everything looks hunky-dory on my side. So just let me know. It is giving me a lot of errors. So let's just keep going. Let's keep trying. Looks fine from here. Thank you, Miss Megan. Okay, good. Okay, I'll ignore YouTube's warnings at the moment. Okay, so let's get back here. We have pick random 0 to 1. Now this is going to represent left or right. 0 is going to be one direction and right is going to be the other direction. And this is going to work because we're going to use an if-then-else statement. So we need to decide, okay, if it's a 1, we need to go left, or if it's a 0, we need to go right. So let's drag the if-then-else statement in. So let's go to control, and let's grab if-then-else. And we're going to drop this just in the canvas here. We're not going to drop it into our code just yet. Now you'll notice that this is one of the bummer parts. I really wish that since this was giving a pick random 0 to 1, and that is essentially a true or false, that it would fit in here, but it doesn't. It's not the right shape. We have this pill shape, but this is the rupee shape or diamond shape. That doesn't quite work together. So what we need to do is we need to go back to operators, and we're going to grab that equal sign. So it is 4, 5, 6, 7, 8 down. Let's grab the equal sign and drag this out. Now we can take pick random. I'm going to put pick random in the first spot, and we're going to put in the second spot that equal sign, after the equal sign, excuse me, we're going to put 1. So what we're trying to do is we're trying to pick 0 or 1, and we just want to see, is it equal to 1? If it's not equal to 1, it's false. If it is equal to 1, it's true. So when it's true, it's going to go into the first section here. When it's false, it'll go into the else section here. We're going to drop this in to the if then else. So again, this one will pick just a random number between 0 and 1. If it's 1, it's going to go into the first section. If it's 0, it'll go into the second section. Now we need to decide what we're going to do. And I've kind of already picked a direction for each of these to go. So I'm just going to start putting this in here. We'll just go with it. And I'll explain it a little bit as I go along. A lot of the code that I do in this section is just to kind of make it look nice. Kind of make it look like it bounces a little bit. It's not really... It's more to just move the ball in the right fashion and get it lined up again so that it can hit the next peg. So what we're going to do is in this first section here, if we're equal to 1, if it's true, if we pick 1, we're going to go in and go to motion, and we're going to turn the ball to point 90 degrees. And so what we need to do in motion, we need to say point in direction 90. Now if I click on 90 here, it brings up an indicator of which direction it'll be going. So in this first section, I'm going to say point in 90 degrees. That means that it's going to bounce to the right. Now let's see if I can get this to do it. If it does it, oh, excuse me, I need to drag this in first. You guys don't have to do this yet. I just want to show you what we're doing. Don't put the code in yet. All right, when it hits and it chooses to turn right, see what it does? It moves and it just keeps moving right. So what we need to do is, since we told it to turn that direction, we now need to tell it to turn back around to keep falling, because we told it to go to the right, but we also need to make it fall down at the same time. So as we're moving to the right, we also need to be following. So it's going to create kind of an arc as it's falling. So we're going to do this by just slowly adjusting its angle each time. So what we need to do is we need to grab in control a repeat 10 and drop repeat 10 down in the right below point in direction 90. Now if you look, we want to keep repeat 10. I figured 10 was a nice round number. I really liked that. If you look, we point in direction 180. That's how we're pointing down, is by pointing in direction 180. But when we move and we want to point off to the right, we point in direction 90. Well, now that we're moving, we have to slowly turn back around to point in 180. Well, since we're repeating 10, what we need to do is we need to move a certain amount of degrees each time so that it's coming back around to 180. So let's do this. What we're going to do is we're going to say each time we repeat, we have to move 9 degrees. And the reason for this is each time we move 9 degrees, we're getting closer to 180. Point in direction 90 plus 90 degrees, which is 9 degrees times 10, will bring us right back to 180. So this is a little math for you here. This is a little working with degrees, working with some multiplication. So let's go into motion, and we are going to grab this one here that turns in the right direction. You see how it spins in the right direction? It spins clockwise. We're going to grab that one, and you need to make sure it's spinning clockwise. It doesn't make a huge difference going the other direction. Or no, it does make a huge difference. I'm trying to remember. It had a weird bug when I tried it the other direction. You want it to turn in clockwise. And we're going to change this to 9 degrees. So each time we're going to change it 9 degrees. So 9 times 10 is 90, plus 90 degrees, which is the current direction we're facing. We will then return back to 180 degrees. Now the next thing we're going to do is we're going to make it move a little bit. And the reason we're going to make it move a little bit is we want to kind of shuffle it out a little bit farther. Right now, I'll show you what it does. Again, don't put the code in the big code section here. When it drops, see what it does? It just kind of gets stuck. And the reason is even though it's turning back and starting to fall again, it doesn't move away from the peg. So we need to make it move away from the peg. So let's grab our move 10 steps and put that right below turn 9 degrees. And just trust me on this number, we're going to make it move 7 steps. That'll make it line back up with the peg that's below it. All right, so I'll show you what this does now. When I drop this in here, it's gonna hit it, and there we go. See how it kind of makes a little bouncing motion? All right, looks good. Okay. Now we need to make it bounce the other direction. You notice that it only bounced right, and the reason being is because if it ever picks 0, it doesn't do anything. So when it comes back around, it's still touching the peg. So we need to make it bounce the other direction. And while I'm at it, you guys are pretty quiet on chat today. Who all do I have? I have Washington Crafter. I have Batman Gamer 3000. Is there anybody else out there that's watching this? Like, speak up. Let me know what you guys are doing. How are you having? You know, are you having fun with this? Are you doing good with it? You know, don't be afraid to say something. Don't be shy. I don't get out much these days. You guys gotta entertain me. You gotta talk to me. All right, so let's get back to this. I was saying that now that we have it bouncing one direction, we also need to bounce it the other direction. So this isn't too bad. We actually are going to create essentially the same thing. However, we need to point in a different direction, and we also need it to rotate a different direction. So let's start with point and direction. Now we pointed, like I said, when we click on this, it shows we're pointing right. We need to create a left. So let's go into motion again, and we're going to grab point and direction, 90, and let's drag this into the else section. Nice, I'm good. I'm glad you're doing good, Batman Gamer. See, someone's speaking up. I like it. Okay, so we're going to click on this 90, and let's make it point the other direction. We're going to point it left. And what left ends up being is negative 90. So we want it to point in negative 90. All right. So now that we're pointing in negative 90, we're going to have the same issue. Again, don't drag your code in. I'm going to show you what it looks like. So when I drag it in here, we're going to get the same issue. It'll try to bounce. See, now you get some funny issues here where it like tries to go left, but it doesn't quite do it. And that's because we don't have the rest of this repeat code in here. But we need to be a little bit tricky with this repeat code, because when we're pointing 90 and we turn it back around, we're making it rotate from 90 down to 180. But we're rotating from left to the bottom now. So where we turn clockwise here, we need to turn counterclockwise when we point in the direction negative 90. So let's go in and start building this repeat section. So go to Control, and we're going to grab repeat 10 again, and drop repeat 10 under point direction. Now let's go back to motion. And just like before, we're going to grab the turn 15 degrees. But like I said, since we're now facing left, to turn back to point down, we need to turn counterclockwise. So grab that counterclockwise one and drop that in, but change that to 9 degrees. Because if we're at negative 90 and we want to point to 180, to come back around, if we're turning counterclockwise, that's subtracting, essentially subtracting 9. So it's going to bring us back around to 180. Now I know that may seem confusing because we're at negative 90 and we're trying to get back to 180. But it's more about the direction in which you move. So they just decided that anything left is negative and anything right is positive. So as long as we're turning counterclockwise, we're still counting that direction. But once we reach negative 180, it actually just becomes positive 180. I know that's really confusing. It's really awkward with Scratch because it's not typical math that we're used to. Normally we start out at 0 up at the top, and then we go to 90, and then we go to 180, then we go to 270, and then we come back around to 360 or 0 again. They didn't do that, and the reason being is they wanted to kind of help you realize when reading the code that when you're negative degrees, you're pointing left. When you're positive degrees, you're pointing right. So what we're doing is when we're turning counterclockwise, we're subtracting 9 from, but once we get back to negative 180, it just turns to positive 180 because it's down. That's how they consider it. So I know it's a little bit confusing, but it's the way Scratch helps us to realize what's going on with our code. So if we remember when we did this, it'll keep turning, but it kind of gets stuck on the peg. So what we need to do is move 7 steps. With this, we don't need to move a negative 7 steps because no matter what, we're always moving that many steps in whatever direction we're pointing in. So it still is positive, even though we're pointing in a negative direction. So let's grab the move 10 steps, and we're going to change move 10 steps to move 7 steps. And essentially the way to think about this is it's moving whatever direction it is, so positive or negative. So if you're saying move 7 steps, it looks at your direction, and if it's negative, it changes your direction by like a negative 7. It's kind of a multiplication thing. Now let's drag this all in and put this if-else statement in the if touching peg. And let's hit the green button and see what it does. And hopefully we get this ball bouncing left and right. That's pretty cool. Bounces left or right. It's random. You'll see that it kind of, the first time it went more to the right. This time it went more to the left. If I keep hitting this, it'll keep bouncing back and forth. There we go. Yeah, not too bad. So you'll start to notice if you keep hitting the green button that the ball tends to fall almost in the same spot every time, or in the same spots every time. And this is what we're going to learn is if it has a 50-50 chance to go left or right, it is going to fall in certain spots more than it will others. And this is what's called normal distribution. I'll let you guys think about this. If anybody has any idea of where the ball is going to fall the most, put it in chat because I would like to see what you think is going on. And Batman Gamer, what is not working on yours? Tell me what's not going on with it, and we can help you out. So I'm going to keep hitting this here while we're waiting for a message from Batman Gamer. And check out how often it's moving one direction or the other and what bucket it's landing in. Oh, look at that. It went all the way to the right that time. All right. Look at that. Not too bad. It's almost relaxing just to kind of watch it fall just over and over again. We're going to change that relaxing here soon, and we're going to make it to where it counts, and so we'll have a big red line moving up through it and showing us some mathematics on it. Okay. So the next thing we're going to do is we're going to add the buckets for this. So what I'm going to do, and again, please, if you have questions, go ahead and post them in the chat. Tell us what's not working, and we can definitely help. Read through the code slowly here. Check it out. I left it up a little bit longer for you. But let's start, and we're going to start adding the next pieces here. So let's go down to the choose a sprite, and we're just going to choose a standard sprite here. So click that button. And I'm going to use button 1. This is the one we should be using here. And we're going to change the name of button 1 to bucket. After going a direction, it goes up. Ooh, that's interesting. So what I would say is that you probably have the turning left or the rotating clockwise or rotating counterclockwise wrong. So I'll show you what that does here. That's pretty cool. See, I get excited about bugs. What if I turn counterclockwise here and tell it to turn 9? So we face 90 degrees, but remember, if we turn counterclockwise, we're subtracting 90 degrees. So if I drop this, I'm going to move this button out of the way. Look at that. It kind of does this upward motion. There you go. Miss Megan has it too. She's all over it. She's got the right idea. So I'm gonna fix my tennis ball though. But you see how if I turn counterclockwise or clockwise, it turns at a specific direction. That's the bug I was talking about. Is that you add or subtract 9 each time. Well, if I subtract 9 from 90 degrees, it's going to be 0 by the time I do it 10 times, which 0 points up. This is cool math. This is the math part that we want to learn a little bit about. So you'll notice that I say this is normal distribution, and in the I can't see it right now, but somewhere in the comments on what this video is, I say we're going to learn a little bit of math. This is the math we're learning. But it's not too bad, right? It's fun when it's coding. Okay, let's get back to this bucket here real quick. Hopefully that worked. Oh, point in direction and not turn. Yeah, that could do it too. Yeah, you don't want to do that. You want to do that rotation, the turn, not point in direction. That's a good catch. Good call. Nice job. Oh, and Miss Megan, she's there's a lag here, so she congratulated you before I did, but it was really after. I said it first. Okay, so let's work on this bucket here. So what I want to do with this bucket is I want to put a bucket at the bottom of each of these sections. So we're going to have to say, okay, go to each of these sections and drop something there. And that something is going to be one of these buckets, but it's going to be a clone of these buckets. Now, if you guys didn't work with us on the matching game, this might be a little bit odd to you. I go through it in more detail on the matching game, and we talk about how to use variables to identify what each of the clones are. So you can give a clone a specific number, and we're gonna do something something very similar to that, and then help track the clone's number and how many times the ball lands on that specific bucket of that clone. So what we're going to do is we're going to first off start creating all these clones, and we're going to place them at the bottom, and then we're going to put in the ability for each time the ball hits that bucket, it's going to draw a line showing that that bucket's been hit, so we can see how often this works. So the first thing we need to do is we need to go down to variables, and in variables we're going to click make a variable. And what we need to do here is very tricky. Normally it says for all sprites. Instead of saying for all sprites, we need to make sure it's clicked and says for this sprite only. That is very, very important in this situation. And the reason being is that if we only make it for this sprite, when we create this variable and create a clone, that clone can remember what the variable is at any given point at that time. So it can say if the variable was 1 when that sprite was created, it will always remember that that variable was 1. If we say it's for all sprites, it will not remember that. It loses its memory. So we don't want to do that. We want it to be for this sprite only so that each clone has its very special memory. And we're going to call this clone ID. That way we know which clones we are. So clone ID for this sprite only, and go ahead and click OK. Again, if you want more details on this, go back to the match game. The match game, I go through this in a lot more detail, and we kind of talk about it, and I show you how it works a little bit better. This is a really neat trick. It is a very cool trick, especially when you're working with clones and you want to identify them as individuals and not as clones willy-nilly, not randomly. We in this case, we don't want it to be random. All right, so let's go to events, and in events, we're going to grab when green flag is clicked, and we're going to drag that in. All right, and Miss Megan's right. We hardly ever do this sprite only, but this is one of those times when we do, and I love it. It's a lot of fun. It's fun to use something in a special way. All right, now when this green flag is clicked, the first thing we want to do is we want to set some variables. So let's go back to variables, and I'm going to grab set, not change, set. That's also a key to this. I'm going to grab set clone ID to 0. We want it to start at the magic 0. And just trust me on this, it's going to be a little bit weird, but we want to go to looks, and we're also going to use show. We're going to grab show and drag that in. And I'll explain that later. We're going to hide this in a minute, or once we create all the buckets, we're going to hide the original just so it doesn't look funny. But this is just kind of jumping ahead. I just don't want to have to go back and do this. So, and then we need to decide where this bucket is going to start. Well, I already decided it. I'm going to make it start in the bottom left-hand corner here. So let's go to motion. And in motion, we're going to grab go to X and Y. And again, trust me on these numbers. I'm going to say it's going to be negative 240 and negative 100. This is going to make it go to that bottom corner. When I click on this code to run it, and it runs just this set of code here, you can see it kind of scoots that bucket over to the side. Okay, and now the last thing we need to do is I want to set its size. So let's go to looks, and I'm going to set size, and I want to change it to 25. Set size to 25. And this will just create just a little bucket for us. Okay, now that we have all the initialization set up, so this is kind of gets everything prepped and makes our bucket look good, puts it where it should be. It needs to be prepped off to the left-hand side. We need to create the clones of this bucket. So we need to tell it to go through, and we're going to make a bunch of clones here. So overall, how many buckets we want is we want one on each side, and then we want one in between each peg. So we need 1, 2, 3, 4, 5, 6, 7. We need a total of 7. So what we're going to do is we're going to make 7 clones because we're going to hide the original. So let's go into control, and in control we're going to grab the repeat 10. But like I said, we only want 7 clones, so we're going to change this to repeat 7. Now, each time we create a clone, like I said, we need to give it a unique identifier. Now, something that's kind of weird with Scratch that's not common with computer science and learning how to code is in code, we typically start to count from 0. But we don't count from 0 in Scratch in all cases. So we need to start counting doing this repeat is we're going to increase our variable clone ID by 1. So go into variables, and instead of using set, don't use set this time, we want change. And change essentially means we're going to add or subtract, and we add or subtract based on the number being positive or negative. This time we want it to be positive. We want it to add one number, so we want to change our clone ID by 1 each time. Now that we have a number created for our clone ID, we can actually create our clone. So let's go into control. And in control, near the bottom, we have create a clone of myself. So go ahead and grab create a clone of myself and drop it below the change clone ID by 1. I'll show you what this does. I don't mind if I click on the green flag here. What's interesting about this is we have these clones, but they're all still in the bottom corner here. So what we need to do is each time we change a clone, we need to shift it over just a little bit. So let's go ahead and let's start that. What we're going to do is, remember, Y is going top to bottom. So if you move positive Y, you're going up. If you move negative Y, you're going down. X is left to right. So if we're moving negative X, we're going left. If we're moving positive X, we're going right. So let's go into motion. And we're going to grab our change X. Don't do set X. We want to change X because we're going to shift ourselves a little bit each time. We're going to drag change X in, and we're going to drag that right below create clone of myself. And we want it to be 80. We're going to move it 80 pixels each time. Do you mean that the bucket doesn't go all the way to the bottom right? Or the ball doesn't go all the way to the bottom right? It's a good question. Okay, so now when I click this, I am going to see that our buckets generate from left to right. So this is kind of nice. Kind of neat, kind of clean. We have 7 buckets at the bottom. We can start collecting stuff. So we need a way to remember what the number is in each bucket. We need to remember how many times the ball falls in each bucket. Oh, you were using 100 for Y? Oh yeah. Yeah, that'll do it. So what we're going to do is we're going to create a list. A list allows us to save different numbers in kind of like a shopping list. So when you create a shopping list, you say, okay, I'm going to get bananas, I'm going to get apples, I'm going to get bread, and that's a list. Well, this, we're saying, okay, the first item in the list is going to represent our bucket 1. Our second item in the list is going to represent our bucket 2. But each of those items, we're going to store the number of how many times that bucket has the ball land in it. And what we're going to do is each time we create a clone, we're going to tell that bucket, hey, I'm here, I'm a clone, I am going to be representing a number in your list. So we need to do a couple things here. The first thing we need to do is we need to create a list. Let's go down to my variables, variables. And we're going to, right below make a variable, you're going to see make a list. Now this you can say for all sprites, it's just fine. It doesn't really matter if all sprites see this or not. And I'm going to call this buckets. And I'm going to click OK. And you'll see that this pops up with a list with a length here. We need to, first off, come back to when green flag is clicked here. And each time we start this game over, we need this list to empty. We need anything that's been previously saved in it to be gone. We don't want to know what happened in the last time we ran the program. So what we're going to do is we're going to come down to make a list here, and it's kind of this darker orange color. We're going to grab delete all of buckets and bring that up and put it right under when green flag is clicked. That's the first thing we can do, is just delete all of buckets. And that'll just make sure that each time we start this, we got a fresh memory. We want a fresh memory. We don't want to remember what happened last time. We don't care. Okay, now what I said is when each of these starts as a clone, we need to actually say, hey, hi, I'm here. Please let me, keep my memory inside this list. I need to let the list know that every time a ball hits me, I have to tell the list to increase by 1 and remember what happened. So that's something that we have to build into when I start as a clone. So let's go to control, and sure enough, we have when I start as a clone as a block. Let's grab that, and then we can go back to variables, and we can say add 0 to whole. So right now it just says add thing to buckets, or excuse me, whole. That's what I initially called it. I didn't like that name though. Add thing to buckets. We want to say add 0 to buckets because we're not keeping track of a string, which is what thing is. A thing is what's called strings, which is letters. We're keeping track of numbers. So we want to put a number in here. That number is going to be 0 because when we first start out, they're all going to be 0, right? Okay. And I did forget one thing. I want to come back to this when green flag is clicked set of blocks here. And I never hid the original bucket that we used. I got all the clones, but the original's still here. And if I can show you, I can move the original. And there's my clones still down there in the bottom. I want to hide my original. So let's go to looks and drag hide to the very bottom of when green flag is clicked, that set of code. So that way when we start this, you'll see that there's no longer an extra down there. So just make sure we hide that last one. We don't need that last one. Okay, so let's come back to when I start as a clone. And in when I start as a clone, what we need to do is we need to check to see if the tennis ball hits our bucket. Now, we need to remember how often do we need to do this. How often we need to do this is forever. We're always checking to see if the tennis ball has hit us. So we need to come back here to control, and let's grab a forever loop. We're going to grab the forever loop and drop it right below the add 0 to buckets. We always want to be checking, is the ball hitting us? Is the ball hitting us? Is the ball hitting us? It gets repetitive, but it's good to be repetitive. So since we're always checking that, we actually need to check it. So let's grab an if-then statement and drag the if-then statement inside the forever loop. So you'll notice when I restarted this the last time, I built 7 buckets inside my list here. And they're all labeled 0, but you see that none of them are increasing just yet. Now what we're going to do is, like I said earlier, we can tell when one sprite has touched another sprite by using a sensing block. So let's go to sensing. And that first one is touching mouse pointer. We can, if I expand this again, last time we only had peg, but now we also have tennis ball in here. So I'm going to drag this out. And I'm going to change this from touching mouse pointer to touching tennis ball. And we're going to drop this in our if-then statement. So here's kind of the goofy thing about lists, is we can't just say, hey, add an item to the list where I'm at. It's a little bit complicated. What we actually have to do is, in computer science, we call this setters and getters, which means that we have to set something and we have to get something. So in Scratch, we can do this all in one piece of code by using multiple blocks. So it'll come out eventually as only one block, but we got to drop other blocks inside there. And the first thing we have to do is we have to say, hey, I have a clone ID. I need to come and look in the bucket over here. And if I'm clone ID 1, I need to look in this clone ID section 1 here in bucket number location 1 and see how many times the ball has landed here. And then I'm going to take that number, I'm going to increase it by 1, and then I'm going to save it back. So the getters part is going in, finding what number is already stored there. Then we do our addition to it, and then the setter is putting the number that we had plus 1 back in. Again, these are called setters and getters. So as we move on to actual code and get away from Scratch in the future here, I might work with some programming languages that actually use setters and getters. They're pretty cool, and the nice thing about them is that they make life easy for us. It may look complicated now, but trust me, when you get into more complex things, it makes life a lot nicer. And the reason you do this is so that it also prevents hacking a little bit. You try to protect your variables so that people can't be malicious with it. People can't do bad things with it. So let's start with this. Let's build this out first to get what we need. So what we need to do is we know we need our clone ID, because if it hits a specific clone, we need to know which clone it hit. So let's go down to variables, and we're going to grab clone ID. All right, now we need the clone ID because we're using that to look at the specific item in a list that corresponds with that clone ID. So if it hits clone 1, we need to look in location 1. If it hits clone 7, we need to look in location 7. So if we go to our variables again and scroll down to lists, we have in this pill section here, we have item 1 of buckets. So we can come in here and actually, instead of saying item 1 of buckets, we can say item clone ID of buckets. So instead of looking for 1, we're looking for the actual clone ID. So let's grab that. We're going to say item 1 of clone IDs, but take clone ID and drop that over 1. So now it says 0 in this case because there's 0 in bucket 1. Because the clone ID I'm looking, or excuse me, 7. Clone ID I'm looking for is 7. Sure enough, if I scroll down here, the number we should get is 0. So that's our getter. That's how we get what number is already saved in our list. That's how we get how many times a ball has. Okay, now we need to add to it, right? So we'd have our getter. We need to add the number to it. So we said, okay, maybe the ball's fallen in there 6 times. We know the ball's fallen in there 6 times, but we're only doing this if the ball's fallen in there again. So let's go to operators, and let's grab the addition sign. And we're going to drop this in the first section of the addition sign, the item clone ID of buckets. We're going to drop that in the first spot. And in the second spot, we're going to add 1 to it because the ball's fallen in there again. Okay, now we've got the number that previously was in there. We added 1 to it since the ball fell in again. But now we need to save it back to our list so that the list can remember what happened. So let's go back to variables. Scroll down to make a list, and we have a replace item, and it says replace item 1 of buckets with thing. Now remember up here when we said add thing to buckets, we actually changed it to 0 because that's the number we want to start with. Well, we're going to say add this number back to it, but we need to tell it where. So let's pull replace item 1 of buckets with thing. Pull that out, drop it in your canvas, and where thing is, what we want to replace it with is our new number. So drop our item clone ID of buckets plus 1, drop that where thing is. Now, we have one more problem here, one thing we need to fix, and that's, let's say right now this is clone ID 7, right? So as our code reads right now is it says get how many times the ball has fallen into 7, add 1 to that. So let's say it's fallen in there 6 times and it just fell in again. We want to get that the number is 6, that's what we have stored. We're going to add 1 to it, we're going to make it 7, but right now it's saying replace item 1, which is our bucket, with that number. But the problem is it didn't fall into bucket 1, it fell into bucket 7. So we need to take this clone ID and we need to put it over here as well. So let's go back to variables, and we're going to take key. We're going to drop clone ID over that 1. The replace item 1 should say replace item clone ID. So this is pretty cool. What we're doing is we're getting the number that's stored, we're adding 1 to it, and then we're putting that new number back over. We're rewriting what that number was before. So once we're done with that, we're going to drop that inside the if statement. Now we need to tell the game something, and what we need to do is, you see that right now, since my ball is hanging over number 6 bucket here, it's constantly counting up. Look at that, I'm already up to 700. In a second I'll be at 800. There it is. Okay, so we're doing something wrong here, and that's the ball only falls once. So we need to tell the tennis ball, hey, it's been caught in a bucket, go back to the top, please. Excuse me. So we're going to do that with a broadcast. What a broadcast does is it allows one sprite to talk to other sprites. So it's essentially one sprite is yelling out into your program, hey, this has happened. So we need to say, hey, buckets, if the ball's fallen into you, tell the ball to go back to the top. So let's go to events. And in events, we're going to say broadcast message 1 here. Let's grab broadcast message 1, but I want to change broadcast message 1. If I click that down arrow on message 1, I can click new message. And I need to type what this new message is, and I'm going to say hit bucket. And click OK. So now I can say broadcast hit bucket. So what this is doing is it's telling the rest of the program, I hit the bucket, and it just sends it out. It sends it out everywhere. And we're going to put this right below the replace item. So now each time it starts as a clone, if the tennis ball hits the bucket, it's going to add 1 to the number of bucket, or to the number inside the buckets. But then it's also going to say, hey, this ball has hit me. Now we need to do something with that. So let's go back to the tennis ball. So go ahead and click on the tennis ball sprite. Make sure that the tennis ball shows up in the top corner here. And we want to use this broadcast. So what we're going to do is go back to events. And in events, now I have it right here. It says when I receive hit bucket. I'm going to drag when I receive hit bucket out into our canvas. And what we're going to do is we're going to do the same thing that we did over here when green flag is clicked. The way we initialized it, we're going to initialize it again. So let's go to motion and grab go to X and Y, and we're going to make those go to X is 0 and go to Y is 170. You see that? It already went to the top. And the next thing we want to do is we want to make sure that it's pointing down. Now, it seems to be working anyway. There may be a possibility of bugs. Don't see, it just missed a peg, and that's why, is because that is a bug that, see, there it goes again right there. That's a bug because we're not facing down right away. So we need to point in direction. So go to motion, grab point in direction, and change that to 180. So we want to say point in direction 180. Okay. So that's not too bad. I see you guys are starting to get some lag. I heard that too, and I am absolutely not sure what's going on today. Everything looks really good on my end, so it might be YouTube. Let me take a look here. All right, just hang with me a little bit. Sorry you guys are having these issues. I'm going to try to change a couple things here. See if we can't get a little bit of normalcy back. Let's see. One more second, guys. Let me try to change some stuff here. Okay, let me know if you guys are getting any more lag. I'm again trying to change some stuff. I don't know how well it's working, but you know, stick with me here. Let's see if we can get this functioning. I'm kind of having a feeling it's a little bit of YouTube today, so sorry about that. Miss Megan, let me know how we're doing. Let me know if you guys are having any lag issues. Oh, I don't have many apps open. That's a good call, though. That's actually what I did. I normally listen to the stream through my headset, and I closed that. So okay, one sec, guys. Just trying to get this figured out. Sorry about the delay. Okay, and I'm gonna keep going just a little bit here. It's not too bad. You can see what's going on, and we can stop it here for tonight too if that's what we need. Um, so what this is doing is now we see in our buckets here, it is counting up. So if I restart this, all of these should start at 0, but each time the ball lands in a spot, we should see it. And we got a little bit of the ball's not quite making it where it should be. There's a little bit of bug there. It happens. I might have typed something wrong, so I can always look back and see if I did type something wrong. Oh, you know why it's doing it. So right here, this matters. This order matters. So we want to turn 9 degrees, then move 7. Not move 7, then turn 9 degrees. That makes actually a big difference. So what I'm going to do is I think I'm going to end it here tonight. I don't know why, but it seems that the stream's having a little bit of problems. My computer's actually working pretty hard right now too. The weird thing is I have nothing really open except for the stuff to use for streaming. So I'm not really sure what's doing it. It happens. Such is the internet, you know. But what I'm going to do is I'm going to actually finish this off. I'm going to make a part 3 video, and I'm just going to post the part 3 video, and I will show you guys how to add the red lines that show us a graph of how the ball is falling in this, so we can see where it falls more and where it falls less. And so I'll finish that up. I'll let you guys watch it. It's actually pretty cool. The neat thing about the video is that we work a little bit with the oh man, my mind is blanking, the pen tool. So if you guys haven't used the pen tool, it'll be something to check out, and I'll like I said, I'll finish this up and we'll check it out, and it will be I don't know, we'll it'll be nice. So let's go ahead and end it here for tonight. I'm going to say, again, sorry about the stream. Not really sure what happened. It's still giving me errors saying that it's not healthy enough. So, sorry about that again. You guys all have a very good night. Please go and stay safe out there. Wash your hands, stay away from people, but still have some fun, and please enjoy yourself, and hopefully I'll see you guys Tuesday. Come check us out Tuesday. JD, like I said, will be on the Zoom classroom as well, and we can all hang out and have some fun. So also we can work on this a little bit too if it's still not working for you. Anyway, again, stay safe, stay healthy, wash those hands. Talk to you guys soon.